Welcome to this video. We will do some practice using the Altair package to create visualizations in Python. First, we need to import the package as well as pandas, and we need to enable the renderer to be notebook. The next step is to load the data, and in this exercise we're going to visualize the Gapminder dataset. We have seen this dataset before. This dataset is basically country demographics data over time. The video that you watched a few days ago, Hans Rosling visualization of country demographics and progress, economic and health progress over time, is basically using this dataset. It's a prime example of storytelling with visualization with data. So in this exercise, we're going to recreate some of the visualizations of this dataset. Let's take a look at some of the questions here. The first question is asking us to relate GDP per capita to the life expectancy, and it's asking us to use the point mark. So the first step to create a chart in Altair is to call the chart function and pass the data to it. Now if I run this cell, I'm going to get an error because basically it's trying to create the chart from an incomplete specification. To complete the specification, we use the grammar of graphics. So we need to specify the marks, the graphical marks, the encoding channels, transformations, and other options to fully create the chart. The first step is to specify the graphical mark. The graphical mark is the geometric object that we will be used to visualize each one of the observations in our dataset. In this case, I'm going to use mark point. What we get here, we get a chart that has 1 point. Basically, all of the observations in this dataset were mapped to this point, were mapped to many points, and all of these points are stacked on top of each other, so we only see 1 point. That's the first step. The second step is to specify the encoding channels. Now, remember that encoding channels are basically visual channels that the human perceptual system can perceive. So there are things like position, shape, and size and color, things that our visual system can kind of differentiate, perceive, and tease apart. So what we're going to do in this case, I'm going to use the X and Y channel to map, to encode the two variables, GDP per capita and life expectancy. And basically what I get what we call a scatter chart. You've probably heard of this term in an introduction to statistics course. It's a very common chart to see how two variables relate to each other. It basically shows how the data is scattered. Now X and Y, I'm going to map X to GDP per capita, and I'm going to map Y to life expectancy, or vice versa. There's no rule that says that this one needs to be X and that one needs to be Y. And we got this chart, and there are a couple of interesting things that we can immediately observe now. We immediately observe that there are some outliers here, which is interesting. And why would we have such outliers? This is a question we can investigate. If we look at the general trend, just ignoring these outliers, we see that the higher the GDP per capita in general, the higher the life expectancy. Though this relationship is not strictly linear, if we look to it, it kind of looks like a wedge shape. It's kind of looking like two lines, right? So there is something hidden here. There is probably other factors that can be put into the chart in order to understand the nuances of this relationship. So let's go ahead and drill down this visualization, try to make it kind of more detailed and try to understand the data kind of in full length. Question number 2 is asking us to use color to differentiate between the different years. Color is yet another encoding channel that we can use to map a variable in our data. What I'm going to do, I'm just going to use my previous chart, and I'm going to map color to be equal to year. And what I get here, basically, I get graphical marks, points in this case, of different shades of color, shades of blue in this case. Earlier years are lighter and kind of later years are darker. So this starts kind of to tell a more kind of interesting story. If you look at the shades of color, although it's mixed, it seems that the higher the life expectancy, the darker the color is, which basically says that over time life expectancy improved. There isn't evidence of that when it comes to GDP per capita, but it's not clear. If you take a look at these outliers, they're light. It means that a country had a very high GDP, but not so much high life expectancy early in probably the 1960s. So what's going on? What observations are represented by these points? It's hard to tell here, but we can use another encoding channel called tooltip. Tooltip is, as the name implies, the tooltip you get when you hover over the graphical mark. This is very useful, for instance, if we want to see more details of the data, but we don't want to plot these details permanently on the chart. I'm going to use the country name to be the tooltip. So I'm getting essentially the same chart, except that when I hover over these points, I get the country name. Now I realize that this country is Kuwait. Now, knowing a bit of history is now no longer surprising. It's kind of the surge of the oil in this country that made this country extremely rich, although its life expectancy in the 1960s was not so high. Let us try to add more information to the chart. And this is the beauty of visualization. We can add so much information, and this information can still be visible and easily understandable, simply because the human perception system is much a higher bandwidth system than cognition. If you take a look at the raw data here, I guarantee that you'll not come to the same conclusions, and those are only 5 rows. We probably have 1700 rows in the data. Let's add population size. So I'm going to use the same code here, and I'm going to use another encoding channel called size. That's basically the size of the graphical mark, and I'm going to map it to population. In this new chart, we can see that each dot now has a different size, and this size is proportional to the population of the country at that year, right? The value of population in the corresponding observation. Again, you have to note that each one of these data points represent a country in a year, so the same country may exist at different points in time, right? That's the trajectory of the United States here. Now, there are more options we can use to specify the scale of the size. Altair will do some default decisions, but we can customize how the size on the scale ranges. You can take a look at the POSIS solutions. It has another chart with a range of the sizes of the graphical marks specified. Next, we will take a look at facets. Facets mean the same chart is created multiple times and will be repeated across columns or rows or column and rows. This basically repeats the same chart, but create those different charts based on a different criteria. This criteria can be a categorical variable in our data. So basically, each chart is created for a subset of the original data. So we're going to break this chart over time. So we're going to create a plot per year. I'm going to copy the same chart specification, and instead of using color, I'm going to use row to create a faceted chart. What we will see here is that we have multiple charts created per each year. Now, scrolling kind of down these charts will give us some idea about how things changed over time. Now, while I'm scrolling down, you can see that the life expectancy has risen from early in the data in 1960s to the 2000s. You can see, like, if you take a look at the latest chart in 2007, that we have like life expectancy ranging from 40 to more than 80. And we can see also that the GDP per capita increased in range. And we also see that many countries kind of has risen up. Now let's scroll up again to early in time, and you can see that if you take a look at an earlier picture of the data, we had life expectancy from low 30s, less than 30s, to above 70. And you can see that the GDP per capita was much more constrained. So all country had relatively lower GDP per capita compared to the data in the 2000s. And you can see that the wedge shape was not really clear. It seems that we had most of the countries falling in the same GDP per capita bucket, but the life expectancy varied a lot. So those are all interesting trends to observe that they have emerged over time. And the value of using Facet is that now we can detect how things have changed because we have a figure, a chart for each year. Question number 6 is asking us to answer the question, how does life expectancy vary per continent? So what we can do here, we can go back to the same specification. I'm going to copy the specification again. And I'm going to go back to color. And I'm going to put color to be the continent again. You can see now that the graphical marks, the points, are colored by continent. Okay, so that's telling something, right? One can figure out that if you look at these colors, one can see that relatively speaking, when it comes to life expectancy, countries in green are doing better on average. There are still some noise compared to countries in blue, countries in red. But this doesn't specifically answer the question, because this question is asking us about life expectancy variance per continent. And what we see here, we actually see life expectancy and GDP per capita. So this chart is too much for this question. Now what I'm going to do here, I'm going to just plot life expectancy as the Y, and I'm going to make my X to be continent. And as you can see here, we have a point representing each observation in the continent, and on the Y-axis we have like life expectancy. So this chart is starting to tell us something. It's basically giving us the variance in terms of life expectancies in between these continents. We can figure out that in Africa there is a big variance, right? From really, really low to almost 70 plus. But if you look at countries like Europe, it goes from 45, 43 and above. Of course, this figure here is telling us something. I mean, one can, if you imagine plotting the average of these life expectancies, you'd probably realize that in Europe it's higher than in Africa, because the average will be dragged down by these kind of laggard countries. So what we can do here, we can further summarize the data by doing a data transformation. This is a topic that we will spend a complete lecture on, but this is a good example of that. We can transform all of these points to one point, which is the average of these life expectancy, by applying a transformation. In this case, it's average. This new figure will have a point, only one point per continent, which is the average of all of the life expectancies on all of the observations pertain to this continent. And this graph is much more meaningful. It's basically telling you that life expectancy in Africa is lower, and then is the lowest, then comes Asia, then comes the Americas, Europe, Oceania, and so on. What's nice in here is that one can do also, color, or maybe we can do row per year or color to be year, and we get different means over time. So this figure is basically kind of saying that, well, I mean, this relationship seems to be consistent over time, but it's shooting up over time. So yes, in Africa, all of the averages are lower than the averages in Europe if you take a look at the same color shade. But you can see that across the board in all of these continents, the average is increasing over time. Again, this is the beauty of the grammar of graphics. By just kind of using these basic constructs, one can come up with different variations of charts and different ways to visualize the data. What I'm going to do now, I'm going to use another graphical marks because we have been using mark points so far. I'm going to use another graphical marks called bar. And if you're guessing what we will be getting, it's basically a bar chart. Let's start with a basic one. My X is the continent and my Y is the average life expectancy. By default, a bar chart here the bar starts from 0 and ends at the Y, corresponding Y, which is the average life expectancy. This is nice because we can see that, well, that's the life expectancy in that continent. We can also flip the axis. I can make the X a Y and the Y an X, and that basically will give me our horizontal bar chart. I'm going to make a variation on this bar chart. I'm going to create something like the point chart. I'm going to create two X's. One will be the minimum, and X2, which is another encoding channel, will be the maximum. This basically will show me the variation in between the minimum and the maximum life expectancy in this in each continent. You may be asking yourself the question, what if we use the color encoding and map it to year? And as you can see here, we've also got a shade of gray here, shade of blue in this case, and we've got different bar charts stacked on top of each other. This one is not very meaningful in this particular situation, so I'm going to take it out. What is meaningful though is to indicate the average in addition to the minimum and the maximum, because the minimum and the maximum is giving us the range, but the average probably is useful because it will give us kind of one observation, one value that we can associate with the continent. So how do we add the average to this chart? Well, the beauty of the grammar of graphics is that it also enables us to combine different charts. What I'm going to do here, I'm going to take this chart here and I'm going to actually use one X and I'm going to make it the average. Now instead of mark bar, I'm going to use mark point. So in this chart I've got 1 point per continent, which is the average. Now the next step is to combine these two charts together. Before doing so, I'm going to change the color of these points, because both of the two charts use the blue color, so if I combine them, I'm not going to see the points. What I'm going to do here, I'm going to specify color to be red. Now you're probably wondering why I use this parameter in this location rather than in this location here. And the reason is that when I use encoding, I'm using an encoding channel and mapping it to a variable in my data, and there is no variable called red. This parameter here belongs to the graphical mark itself. Indeed, if you check the documentation for the function mark point, it will probably tell you about the different bunch of parameters that it will take. Let's take a look at this function. I'm going first to create a chart object and then inquire about the function mark point. And as you can see here, there are many parameters that we can use in order to kind of fine-tune how the graphical marks show up on the figure. One of these parameters is color, as we have seen. Okay, so I've got two charts here. One of them is showing a bar chart going from the minimum to the maximum of life expectancy, and one of them is a point chart. I'm going to combine these two charts. So first I'm going to save each chart in a variable, so I'm going to call this one chart 1 and I'm going to call this one chart 2. Now notice is when I assign the chart object to a variable, I don't see the chart anymore. If I want to see the chart, I need to type in the variable so that the chart will get rendered in the notebook. Obviously, I forgot to take out the color here, and I've got an error message. There is no red variable in my data, so that's chart 2. But I don't want to see chart 1 or chart 2. I need the two charts, and I'm going to use the plus operator because I want to stack chart 2 on top of chart 1. And this is what I see. I see a point in red on top of the bar chart, which is nice because I can see the average now in addition to the ranges of values of life expectancy. Now finally, instead of using point, I'm going to use the tick, a graphical mark. A tick is just a small vertical line. As the name implies, it shows as a tick, and it's very useful to specifying, one single value on a bar chart, like in this case. Finally, let's take a look at the last question. How did life expectancy change over time? Again, there are many ways to visualize this change. I'm going to create a line chart here, which is one of the classical ways to visualize change over time. Now what I'm going to do, I'm going to create the chart object from data, and then I'm going to use line, mark line. Next, I need to encode, you probably cannot visualize a line without sufficient encoding. So I'm going to encode my x to be year. Usually y, the x-axis is time in line on those kind of timelines. And my y would be life expectancy. Now you can see that you've got a very jagged line. And the reason is that per each year we've got multiple values of life expectancies, hence the vertical line. I want to condense all of these values, so probably it makes sense to use average life expectancy rather than life expectancy. And that's the trend line. It basically shows the increasing life expectancy over time. Now this is a general trend, and the question is basically asking us to answer how did life expectancy change over time. It has increased over time. But again, we can get into the nuances of this change. We can probably create different line charts by mapping color, for instance, to continent. That probably show the different line charts per continent. So you can see that across the board, life expectancy has changed, although generally speaking, Africa still lags behind Asia, behind Americas and Europe. On the other hand, if you take a look at the beginning relationship, you can see that Asia kind of approach Americas and Europe, so the gap has closed over time compared to the gap between Africa and Asia or Europe. Again, we have access to all of the different encoding channels that we learned about. So maybe I want to use this, I want to create a facet, I want to create a row per continent, and I get a row per continent here. And maybe in each continent I want to show the different countries, so then I can do color equal to country. And then I've got multiple line charts per each continent. Each one of them maps to a certain country. Obviously it's very hard to see because there are so many countries here, so maybe this particular chart is not very useful, but it can be useful as an exploration of the general kind of relationship. Now each line, if I hover over it, because I use the tooltip, is going to tell me the country associated with this line chart. So this concludes this exercise, and my goal here was to show that by mastering the grammar of graphics, it's possible to create a large variety of charts by using this basic construct, the graphical marks and the encoding channels. We will do some more advanced practicing in the next exercise.